Welcome to the Founders of Web3 series by Outlier Ventures and me, your host, Jamie Burke. Together we're going to meet the entrepreneurs, their backers and the leading policymakers that are shaping Web3. Together we're going to try to define what is Web3, explore its nuances and understand the mission and purpose that drive its founders. If you enjoy what you hear, please do subscribe, rate and share your feedback to help us reach as many people as possible with the important mission that is Web3. So today I'm really happy to welcome Sergey Nazarov, co-founder of Chainlink. Chainlink are all about smart contracts being connected to real-world data, events and payments, providing a reliable, tamper-proof inputs and outputs for complex smart contracts on any blockchain. Welcome to the show, Sergey.
Thanks for having me, Jamie. Great to be on the show. Thank you.
So just to expand a little bit more on Chainlink, we're going to go into this in much more detail over the course of the podcast. But effectively, you're solving for smart contract external connectivity and the kind of middleware problem so that web developers and fintech developers, smart contract developers on various networks can build fully functional smart contracts for production use at scale. As I kind of look into the background of the people that come on the show to add a bit of personal flavor, you offer some words of perspective on life, presumably drawing upon your early years as a philosophy student, which is really interesting to see. So I kind of pulled out three. Genius is 1% inspiration and 99% perspiration. Thomas Edison. Every new beginning comes from some other beginning's end. Seneca. And this time, like all times, is a very good one if we but know what to do with it, by, again, Emerson. So I think those three are very relevant for Web3 and many of the problems that we're solving for. Are they the three best ones? I've omitted some others out, but I don't know if they're fully reflective of a Sergey today.
Yeah, I think those are all very good ones. One other one I like is, if one does not know to what port one is sailing, no wind is favorable. That's also by Seneca. That's also listed somewhere on one of my social pages. And another one is, we must stand upright ourselves, not be set up, by Marcus Aurelius. And it's kind of around putting things in a position to succeed and knowing where you're going and having focus. I think the thing with the blockchain space is that there's so many different ways that the technology can be applied. And the people that are really moving forward and creating progress are the ones that are able to focus and make a specific decision about this is the thing that they want to do particularly well. And I think that's an evolution of the space that starts to mimic what you see in more developed industries, where you have people owning a piece of a stack or a certain subset of problems and being very good at solving those problems. And then other people are very good at solving other problems. And so I think in addition to those are very good ones, but in addition to those, the ones that really talk about having focus are very important.
And I think all of them very relevant in the context of being a founder. And it's strange, a number of founders I've interviewed on the show so far, and a large or a kind of outsized percentage of them have some background in philosophy. So I don't know what it is about Web3 and crypto that attracts these type of people. I myself actually did a philosophy degree, dropped out though. So that there is something about the space that attracts our type. So the reasons why I've got you on the show, there are a number. Firstly, I think you're solving one of the most fundamental problems in Web3, the Oracle problem. Oracles as a kind of trusted data feeds for smart contracts are perhaps the most tangible way this new web, this new world we're building connects with the old one. So you're kind of at Chainlink, you're both literally and figuratively bridging Web 2 to Web 3. You've also been hugely successful in scaling with ecosystem growth. And of course, that's the one thing that all founders are trying to achieve in Web 3. So I think there's going to be lots of interesting lessons there. You've become somewhat of a cult figure in the space and certainly within your community. And so again, from a founder perspective, I think it's interesting to understand how you kind of handle that fame almost that comes with being a founder in Web3. So by way of background, a quick summary of how you got here. As I said, you studied a BA in the field of philosophy and management at New York University. You're also on a debate team, obviously. You did a teaching fellowship at NYU Stern back in 2010. And then I believe the story has it, you did a number of different things and startups, but ended up in the blockchain space in 2011 through mining before you went on to found your first kind of application, Cryptomail, in 2014. So what was it that brought you into the blockchain space? I know you said not a lot of people know the mining connection, so it'd be great to understand that origin story.
Sure. I think the thing that brought me in initially to the space was I did always have an interest in digital currency because it's related to gaming. So I did have an interest in gaming. I did play PC games in the past. If I ever have time, I play PC games if I can find time, which I really can. And I knew from the history of digital currency, which is, as long as kind of the history of the internet itself, even since the beginning of the internet, you had a whole bunch of different digital currencies coming around, that those digital currencies usually depended on a central kind of company. So you had a lot of fragility in the digital currency's ability to retain its value over time. So you basically had somebody who made digital currencies for loyalty points or flight points or some kind of gaming digital currency. And there was a whole bunch of different dynamics around where either some company closed down or they switched the rules, or they changed the conversion rate of the points or the currency to some digital good somewhere. And the way that I initially found out about Bitcoin was through this path of there's some kind of new digital currency. It's called Bitcoin. It has these new dynamics. And at first I didn't understand the dynamics. There are a bunch of different digital currencies out there, and that's kind of, they all kind of sounded the same. Then when I actually started looking into Bitcoin more and understanding how it's different, I think the thing that struck me was 2 points. The first point that struck me was that there's no company, right? So that's the thing that was quite unique, where before there would be many failure scenarios where the company building the digital currency would stop building it and that's it, and the thing would stop. And this would be the way that a lot of digital currencies, no matter how much value they accrued, they would stop accruing that value. And this longevity was unique to Bitcoin. The second thing that happened was when I actually put up a CG miner and started mining and started working through some of that stuff where you actually get Bitcoin through mining, was kind of just an interesting thing to do. I kind of realized that there was some kind of piece of software that I was running that was giving me something of value that was disconnected from anything else. So there wasn't a game attached to us. There wasn't an entity attached to it. There was just some kind of piece of software where I was doing some kind of computations and I was getting something back. And I knew that you could go buy something. You could buy a magazine subscription. You could buy a shirt. You could go get something. And I started to realize that this was all quite different. So I started to realize that this is not attached to the same ideas of digital currency, where there's points or there's some centralized entity or some game, that there's some kind of unique dynamic here that I'm doing some kind of computation. I'm running this thing for some reason. As I looked more into it, okay, fine, I'm helping secure the blocks, hash power, so on and so on. But I think the unique thing was this separation from an entity and the capacity to make sure that the value continued to exist, and also that you didn't actually have to do any kind of other deals. Like you didn't have to, you had to supply electricity and you had to supply hardware, but you didn't have to do a deal where you got something from somebody, you converted it into a different good and you sold it to somebody else. You were able just to run a piece of software that made you money. And that's pretty unique. I hadn't heard of that before throughout my career of building technology companies or working with them or anything like that, where you could just run a piece of software and it made you money. That as just a random person on a computer somewhere. Those two things were pretty unique. And then the mining continued for a number of years until you had the emergence of what were then called app coins. And the app coins were the first uses of blockchains for things other than transactional data. So the first big shift in the space wasn't even smart contracts. It was just, I have data other than transaction data that you can do something within a blockchain. So it wasn't even as complicated as here's a smart contract that's going to process all this logic, it's going to manage funds, it's going to do all these things. It was more along the lines of blockchains can move transactional data the way payments networks do. Well, what other things can they do? Can they move message data? Can they move ownership data of other types? And this was what app coins, some of the first ones were about naming records through Namecoin and others, right? So you basically had what other data can I layer into a blockchain? So my journey in blockchain land kind of really began at this level. It didn't begin at the level of let's make a token or let's make a smart contract. It began at the level of people reasoning through what else can I use a blockchain for? And at that point, there weren't a lot of people doing it. So you kind of had to go and interact with the communities that built these different things. And there were a few people like me that were going to meetups and interacting with various founders of various infrastructures and seeing how they could be combined or used separately. And that trend of infrastructure has continued. I think the way that it's evolved is based on usage, right? So there was a lot of token usage. So a lot of people became really excited about better and better systems around tokens, which makes sense. And you have usage, you want better systems to help manage that usage. That all adds up. My start in all this was how do we use blockchains in more advanced computational kind of situations, right? The first thing that we really tried to do was to go beyond payment data and to go towards message data. So there were some of these chains that basically said Bitcoin is extremely limited on the amount of arbitrary data that you could put into it. It can secure that data effectively through something like op return. And then they started pumping data in there, and the Bitcoin blockchain folks didn't like that because that wasn't the proposed use of it, right? It wasn't the storing of Bitcoin transactions and securing of Bitcoin, is the storage of some unrelated data. So then some amount of chains began to innovate and say, hey, why don't we make some chain that can have 40 kilobytes, paragraphs and paragraphs of arbitrary data that you could put into a transaction or a block. And that feature in and of itself, just the ability to put more arbitrary data into a blockchain, opened the door to a lot of things. It opened the door to some of the first work that we did with secure messaging, where you would take messages, you would encrypt them encrypt them in the client. So JavaScript on the client side would encrypt the message, broadcast it to an on-chain environment that would store the message encrypted, and then the decryption would happen in another JavaScript client-side interface. So this means that the actual plain text never ended up touching a central server. So the unencrypted message doesn't go to a server. You can't intercept it. It's all done client-side, and you have some level of persistence because you have the encrypted kind of ciphertext, message text on a blockchain. And this was more than anything kind of an experiment to see, could this be built? Because I had certain doubts about whether the transaction securing model of Bitcoin and blockchains could be extended to other types of data. And this was in a time when secure and private messaging was a very hot kind of topic. And so we just decided, hey, why don't we apply blockchains to this problem of data privacy and private data transmission in a way that can solve it better than centralized systems, because plain text never ends up going to the server. You can't ever intercept it at a central server. To my kind of surprise, it was very doable. So it was a very doable configuration of the blockchain's capabilities with this more advanced arbitrary message text capability and what people were seeking to achieve for private message transmission. Now, that service actually started to get certain amounts of demand and certain amounts of people contacting us and all that type of stuff. And we just decided not to go into that industry because the secure, highly private messaging industry is a very sensitive place. And, the ability to build something with longevity there is also very complicated. People can send all kinds of strange messages that you may or may not want to be related to. And there's a whole bunch of dynamics you don't necessarily want to be involved in. So the private messaging space was an experiment. It went very well. Cryptomail showed me and our team that we can use blockchains for other types of data. And then we kind of began thinking, well, what are the types of data that blockchains can relate to? How can they be applied? What is all the other data that they could be related to? And as we started thinking about that more and more in 2014, we kind of realized that there's pretty much no limit. The only limit is the one where if you had the choice between a highly trustworthy system and the untrustworthy system, you would choose the untrustworthy system. Like you would choose the system with less reliability, less security, assuming that the efficiencies eventually became the same between two systems. And it was on this basis that I basically made a decision to devote kind of a lot of my time and basically at this point a substantial portion of my life on an absolute and on a daily basis to the implementation of this technology around all this other type of data. Because I really couldn't answer the question of, if you were able to make these systems equally efficient, why would someone prefer a less secure, less reliable, more tamper-proof system for their interaction with ownership data, with financial securities data, with global trade data, with insurance data, with marketing data related to ad networks, which have a ton of fraud, even gaming related data, digital goods ownership? The real question kind of starts to become, if you could make everything into a smart contract, into a blockchain-based record, because you had the efficiency to do that, why wouldn't you do it?
Similarly, as I think you're aware, for us, we entered the space roughly about the same time, 2014. And as you say, there's this kind of period of experimentation, like pushing the possibilities of the technology. But quite quickly, we arrived at the same thing, which is ultimately this is all data. We're talking about a new data economy. And, a blockchain is just a means to coordinate, secure, transport that data.
Right, exactly. I think the way to reason about this more holistically is, where can the tamper-proof guarantees of a blockchain be applied, right? And how will they be applied? And that's really the question. And then you can go industry by industry and sector by sector, and you can reason about what are the requirements that a blockchain-based tamper-proof system needs to meet for these various sectors or various use cases. And the various use cases have very different requirements. So that's the other thing that I think is also important to understand. It's that there's a lot of variability, because all the different digital agreement types you'd be dealing with and all the different data types are very different, right? So a system that's very, very good for payments transmission might not be the best system for making tokens. And the system for making tokens may or may not be the best system for global trade and supply chains. And the system that's very good for, it's sometimes more specific. Now, there are very good general purpose systems, and I think that smart contracts, generally speaking, as a layer to manage all the logic involved in these tamper-proof contracts, there does need to be a general purpose, globally shared source of truth, golden record layer that in many ways will eventually replace even people's use of databases, because the databases often keep so many redundant records between parties because they don't have an intermediary shared golden record that they can rely on as much as their own database. You do, I think, need a general purpose system. I think there's all kinds of things in scalability that people are doing and help grow adoption there. I think the way that really helped me think about it was, don't necessarily focus on what blockchains are doing today. Really try to understand what are the guarantees that blockchains provide, and then maybe even starting at the places that you understand best. Think about, where can that be applied? The next thing that we worked on was a kind of decentralized exchange interface and a decentralized exchange model, where you had one of the first and for a certain time the most widely used decentralized exchange that was able to not only exchange tokens but layer on revenue sharing and other things, and this was secure asset exchange. And this was the more advanced use of smart contracts for essentially exchange data and some amount of also revenue sharing, where you would be able to distribute fractional kind of payment out to token holders. This led us to start to think more about smart contracts as a general purpose framework. And that's when we kind of moved on to make sure that there was a more general purpose system. That's when we really shifted focus to working more on smartcontract.com. Smartcontract.com was a focus on how do we compose smart contracts for various verticals. Some of the first verticals, some of the first ones that we were able to get running was things around shipping, things around search engine optimization. So search engine results can be verified from public APIs even, and you would be able to see, if I paid you this much money, you would get my search engine rank to a certain ranking, and that ranking would then result in payment to the search engine optimization firm. And the user isn't holding the payment over the search engine optimization firm, and the search engine optimization firm isn't holding the payment and making false promises to the user. So it was kind of like strategically looking for situations where you can create a better trust dynamic on a vertical by vertical basis. Then basically what happened is a number of banks started showing up, a number of banks, insurance companies, fintechs, insurtechs. And we started working with them on a number of either using smartcontract.com or using a more advanced version of the backend that we built. And we basically arrived at a realization that what these people needed was an abstraction layer. So they needed a layer between the blockchain they wanted to use and all the other things they wanted to do with it. So they wanted the blockchain contract to know about something in the real world, like the shipment of a good or the market price change or weather for insurance, or whether an ad was viewed on a web page or something. 50,000 different things that people want to do with digital agreements. And the blockchains that they were trying to build this on, this is even, I think, before Ethereum is live, and then Ethereum goes live, and it evolves a little bit from there. But I think the thing we realized from actually working with a lot of these use cases was, even if people were able to get some kind of state change working on a blockchain somewhere, the issue that they were going to have was, once I get that state change working by having a private key replicate some kind of interaction with data, the actual interaction with a data source or sending a payment somewhere that isn't on the blockchain is going to have a lot of security issues, and it's going to have a lot of failures and points where you can really break the model of a smart contract. Because I think the other thing that's really important to understand is, what is the model of a smart contract? The model of a smart contract is not the same as the model of a digital agreement. The digital agreement basically has a central company with funding, with a logo, with a brand. And the brand says, trust me. I have a nice big brand. I have my brand on the top of a big skyscraper in New York. You should trust me. I'm solvent. I can pay you out as needed. Here's my brand, Wirecard, my brand on a big building somewhere. It's fine. Everything's going to be fine. And that's the model, right? I'm going to run the digital agreement. You're going to connect to it via APIs. Trust me, it's fine. I have a big brand. I have a logo. I have some certification, some sticker from somebody that says I'm a good person, good thing that's going to work. Something happened with me, right? I have some checkbox. It's going to be fine, right? So that's the model of digital agreements. And I guess, yeah, that model is an improvement over not having that model. Absolutely. If I have a choice between digital agreements and paper agreements, digital agreements, absolutely. You can automate things with data, fine. But smart contracts say something very different. Smart contracts say there's no brand, there's cryptography. There's a mathematical guarantee that if you do X according to this contract, you will get Y. It's not a matter of a brand or a logo or a certification sticker from somebody, good marketing, fuzzy, I'm your friend, we're gonna not be evil together thing. It's just like deterministic physics, fact of life level stuff. And that is a huge difference. So that difference eliminates the possibility for people to basically not follow through on their commitments, whether they're a large entity and you're a small entity. It changes the power dynamic, whether you're a single user and they're a big kind of entity that monopolized all the data and all the interactions you have with other users. This can't happen anymore, right? The power dynamic completely changes, and you're no longer relying on someone's brand or some people somewhere, which is actually, as brands fail for whatever reason, as the trust that people have in a brand telling them it'll be fine, just don't worry about it, as that dynamic begins to give way to a better guarantee, a cryptographically enforced guarantee, I couldn't explain to myself why the hell anybody would choose a brand. I just couldn't understand it. I would be like, It would be like saying, I'm gonna throw something and there's a 10% chance that it's gonna go in the hole and I can win a toy, or I can just throw it and the laws of physics work properly and I know it's gonna go in the hole at the carnival and I'm definitely gonna win a toy. It's like playing a rigged carnival game versus a fair carnival game. Like, why would I ever not play the one that's definitely gonna work correctly? So this is really the nuance that I think people should focus on. And then all the infrastructure that people are building is, how do we do that, right? So how do we represent ownership in a blockchain through tokenization? How do we get that tokenized ownership into a contract where it can earn interest? How do we generate some kind of derivative financial product from that? How do we generate an insurance policy around something like weather? So when you start hitting the more advanced use cases, you start to see, oh, okay, I need to know what the weather is. But if you want to maintain that guarantee, right? If you want to maintain that cryptographic proof guarantee, you need to extend it to your relationship with weather. You can't have it stop at the level of the blockchain is doing a state change. Fine, the blockchain did a state change, that's great. But if the blockchain did a state change and some other system that's very easy to manipulate completely controls that state change, well, if you average out the amount of actual tamper-proofness you've achieved, it's pretty low. However, if you can validate and you can actually prove at a very high level of deterministic proof and guarantees that the weather was actually no rain for the 6-month period of the insurance policy, then you can make a deterministic true smart contract for that category of events, right? And that's really the goal that we're engaged in moving forward. We're engaged in, how do we take the blockchain infrastructure that exists, that many smart people are working on, many great people are moving forward in amazing and very complicated ways, and how do we extend that to all of these other use cases? How do we extend it to be useful for, I want to write an insurance product around the weather so that a farmer can now have weather insurance even if their local government can't support the existence of an insurance company? How do I do securities markets transactions between two countries that don't trust their respective legal systems because of political issues, and I don't need to rely on the political systems or the legal systems of those two respective countries that have tension, but I can still do a securities transaction between them because I don't care about whatever's going on. I just care about doing that transaction, and I need guarantees about it properly happening, right? How does somebody gain ownership of something and know that a bank or some other entity can't simply shut off the ATM and tell them that they can only take out 66 euros per day, and that's the new relationship that they have with their savings, right? How can we extend all of this functionality to more data, more use cases? And this requires this abstraction layer. And in our language, we're seeing this as the creation of universally connected smart contracts. That's what we really see as the next generation of these contracts, is they're universally connected to everything you want them to actually influence. They're connected in a way where the reliability that something actually happened out in the real world is so well validated and so proven to the contract that it meets the same level of guarantees as the contract. And therefore, that's when you have a smart contract about that category of activity.
So a lot of what you've kind of described there is, in summary, this idea of the Oracle problem, and that kind of articulation of this universal solution is, I guess, how you describe the Chainlink's approach. How do you solve for the problem of quality of data and this kind of rubbish in, rubbish out problem?
Yeah, so that's definitely a complicated problem, but that is the problem that we're working on and we're solving successfully in certain verticals. The model of smart contracts is that you have decentralized computation. So you basically have independent parties or entities computing the same thing multiple times, coming to consensus that this is in fact what's going on, right? This is in fact the transaction that's correctly sending tokens or coins from address A to address B. We've all agreed on that, and so many of us have agreed on it. We've validated so much and so many times across so many people that we're with the help of cryptography and certain solving of puzzles and math problems, you kind of arrive at a place where so many people now store that conclusion, so many people have agreed on that conclusion, that conclusion is considered definitive, right? And so that's decentralized computation. So the logical step here would be to say, okay, decentralized computation is getting invented. It's coming into existence. It's going into this early to mid state of being polished and adoption. How do we apply that to this problem of validating the outside world, right? How do we do that? Well, you basically need two dynamics. You need a dynamic where you have multiple independent nodes, entities, computing systems that are independent from each other, validating the world. And then you need multiple sources of data that should be saying the same thing. And so the creative thing around building an Oracle framework or an abstraction layer like what we're doing is that you end up needing to make a very flexible system so that every unique situation that you're in, whether it's a smart contract security, whether it's smart contract insurance, whether it's something for ad networks to eliminate fraud, they will all have different data sources. They will all have different ways that they want to interact with that data. And they will all have different requirements about the privacy of that data, even when it's in this Oracle network abstraction layer. And so what you really need to do is you need to build a flexible system that allows you to have multiple independent nodes that meet the requirements of a use case. They don't meet the fantasized requirements of us. They don't meet of the people building it. They don't meet the fantasized requirements or even the real requirements of a single use case, right? Because that'll probably only work for that use case, right? You make something for smart contract securities. Oops, insurance wants something else. Oops, trade finance needs a whole different way to interact with data or different dynamics around interacting with data. And so examples of this are things like, oh, I'm going to go and I'm going to validate prices from multiple sources using multiple nodes. Okay, great. That can work for crypto data. That can work because you have multiple sources. It's very fragmented. There's a lot of exchanges. There's very little lock-in across exchanges. Volume shifts very rapidly. And you need to solve those categories of problems, right? You need proper market coverage of price. You need to make sure that there's decentralization of data sources. You need to make sure it's coming from the source. You need to kind of solve a specific subset of validating the outside world using this Oracle mechanism abstraction layer. Then you have other use cases where you have insurance. So if you're insuring a field of solar panels, let's say there's 10,000 solar panels and every 100th solar panel has a sensor. Well, then what you would need to do is you would need to reason about, well, how do I get all those sensors feeding into my contract correctly so I can properly insure this field of solar panels? I don't just want one sensor, right? That's a big risk. Even if I have decentralization at the middleware level, I want to figure out a way where I can properly have the different sensors giving me data about this solar panel field. Maybe I want the sensors signing the data at the origin and sending them to me that way. Maybe that's the right model. Maybe the easiest way to do that is to give some lightweight piece of software to the sensors. It's something that evolves with different use cases, but it always comes down to two dynamics. It's who is validating the data at the decentralized computation level, who are the nodes validating the data, and then what are the sources of the data. And when you have situations that are single source, so when you have situations where there are less sources, then what you begin to do is you begin to strengthen the relationship as much as possible between the source and the contract. Usually with the way we approach this is we actually get the source to run the Chainlink software themselves. And so they're both the source and they're signing. And then what you look at is how do we strengthen this kind of relationship between data and the contract? And then also very importantly, you would want this system, as our system does, to prove to people what's going on. So another big dimension is the proof that a blockchain or a decentralized middleware like ours can provide about what is actually happening with the delivery of data that's triggering a contract. And this is something our system excels at as well, because if you're going to move from the world of I have a brand, don't worry about it, it's fine, to the world of, Verus and Numeris, cryptography is proving to you that if you put this much value into this contract and you do X activity, you will get Y output. And that's not dependent on a brand or a government or a legal system or anybody. It's just dependent on physics and mathematics working properly. Then you need to prove that to people. And the system needs to have a capacity to prove that, just like blockchains prove that. And so those are, I guess, the three dynamics at play there.
Obviously, at the moment, we're speaking in July, and depending on when people actually listen to the podcast, DeFi is very hot right now. It's where a lot of attention's going. Chainlink and these kind of things are open source, so in theory, anybody can take them and apply them. But obviously, you also kind of have a business. Are you being pulled as a business into DeFi with that momentum? Or are you kind of actively exploring, because DeFi is primarily on-chain, right? It's a series of on-chain events versus what you're saying, the ability to connect with effectively off-chain data sets. Where as a business are you being pulled versus the protocol and how people might be using it?
So yeah, we don't necessarily view ourselves as a business. We view ourselves as an open source project, an open source product that's enabling the implementation of smart contracts in a way that they're going to become the dominant form of digital agreement. Our goal is to enable that shift in how smart contracts are used for things beyond tokenization, basically. So our goal is to take our industry, the blockchain industry, into the new world of decentralized financial products, decentralized insurance, decentralized global trade, fraud-proof ad networks, fraud-proof gaming. And I don't think it's a coincidence that decentralized financial products are taking off when there's better and better oracle mechanisms and abstraction layers like ours. I think it's all very connected, because even in our case, we have cases where users came to us, were able to integrate in a number of weeks, didn't have to build infrastructure, just like they didn't have to build a blockchain, didn't have to build an abstraction layer, didn't have to build an oracle mechanism, which is a serious set of security and computer science problems. And after launching, in a matter of 6 to 9 months, we're able to get over 100 million in value secured. And that's part of what's counted in DeFi, right? And we have other users who are able to rapidly launch new markets because we can provide new data to them for them to launch new DeFi markets in the derivatives category. And those users are great teams like Aave in the first case, and then Synthetics in the second. And we're very, very proud that we have something to do with that. So we don't really view it as like, here's this business and that type of thing. We're very lucky to be in a position where we can, for the long term, build an open source product. We have the resources to do that. We're very, very lucky to have those resources. We're able to deploy those resources to build an open source standard, which is being adopted more and more as a standard. And the goal of our team and our group of people and our body of work is to change what smart contracts are about, to essentially redefine this industry from tokens and exchanges to everything else. That's not saying tokens are wrong in any way. The tokens are great. Tokens seeded the space with value for people to put into contracts, at least in these initial DeFi formats. But there's an evolution that needs to happen here. And in fact, it's the evolution that I have been working on for, I think, over 7 years now. And I'll be working on it for many, many more years. And it's something I'm very committed to, and I believe in from a, you were saying before about philosophy, from a really moral point of view and ethical point of view. I think that making contracts function correctly is really one of the things that more and more advanced societies have done. And then as more and more advanced societies are able to do that, you see people have more time for art and science and invention, and just quality of life improves, and society becomes more civil and more the type of society that you see in science fiction things that I read, like Star Trek and all these amazing things that are like, here's the future. So I think our goal is really to make an open source standard that becomes a public good for how people build these contracts the right way, They can do that on a multitude of different environments. And I don't think it's a coincidence that DeFi is taking off, new markets in DeFi are being launched. I mean, we have a very large amount of mainnet live users now. I can safely say that we're the most widely used Oracle mechanism right now on public blockchains. And that's only accelerating into DeFi and into fraud-proof gaming. I think the way to think about it is once you give people features that they can efficiently use while maintaining security, that is when our space begins to do more cool stuff, right? So what Ethereum did was it gave these people an ability to make tokens both efficiently and without having to worry too much about the security, right? Like they have to write it securely, they have to get an audit, but it's doable. And that's why everyone made tokens, because all of a sudden you could make tokens. You could efficiently and securely make tokens, and there was a boom in tokens. I don't think it's a coincidence that DeFi is taking off when Oracle mechanisms are around. And I think many of our users are driving a lot of that DeFi growth, and many more of the people driving that are in the process of integrating us into their system and kind of, I think that's the really exciting thing for me and for our team is that we feel very proud to have a part to play in how all of these DeFi products are redefining our space. And that's why we don't make a DeFi product. We don't make a blockchain. We enable all these other people to basically combine an idea for a great financial product, a tamper-proof contract that isn't based on brand, but based on cryptography, together with blockchains. Because they now have an abstraction layer, they now have an Oracle mechanism for them to make this universally connected smart contract. And that's the overarching goal that we have. Like our successful outcome is the world is running on smart contracts as the dominant form of digital agreement. There's the abstraction layer that we made powering the interactions that all those contracts have with everything else in the world, other payment systems, other data sources, chains, any number of other resources. And that's the thing that we're devoting our time and energy, pretty much in many cases our life to. So that's kind of our priorities.
So do you think, perhaps this is a philosophical question, but do you think that, let's just use DeFi as a catch-all term, that DeFi has the potential to go over the top of the world as it is, the existing financial system, including insurance or, as you say, supply chain finance? Or do you think it's more likely that we'll see incremental decentralization of the world as it is, or could both be true?
I mean, I think it's both. I think people are going towards the same place from different directions, just like they were with the internet. So in the internet, you had startups that were starting out internet first, and they're like, I'm internet first and I'm going to win because I'm e-commerce internet first. And then there were some companies that were able to do the proper analysis and do the math and do the numbers and think about this in a more holistic, deeper way. And they said, this internet thing is gonna force us to really reinvent our business. And if we don't do it right now, well, we're gonna have a huge problem, not just because these startups, but because my other competitor would do that. And so I think it's exactly the same here. Like there's this term Internet of Contracts that was popular before but isn't popular now for some reason. I think everybody will eventually just go towards saying, yeah, this was my plan from the beginning. Just like everybody eventually got on the internet, right? Like all these corporations that before, I'm sure you can find quotes from wherever in that organization saying, the internet, it's a joke. They laid all this cable. All the cable they laid is worth this much money, but the value and traffic on the internet is only worth that much money. Oh, it's such a waste. Or, they laid all the broadband. It never gets used. I'm sure you can find quotes from all these companies, many of which are dead, some of which still exist and are now powered by internet-based interactions with their customers internally between the people that work at the company. I think it's the exact same thing here. I think there's just a new dynamic that you can do on the internet, basically. Like just in the evolution of the internet, you had unencrypted email. Okay, fine. I have unencrypted email. What can I send using unencrypted email? I can only send a certain category of things. Then I have encrypted email. Then I have encrypted HTTPS transfers of credit card information. Oh, wow, I can do e-commerce now. Isn't that fascinating? And it's the exact same dynamic, right? It's just kind of, you'll have startups that say, I'm crypto first. I'm going to become the world leader in X category of contracts because crypto is the future, and because I have a really competent team that's able to make really high quality financial products that are based on providing real value, not purchasing users, not like something else, but on the fact that my financial product has unique real value to provide, right? And that's what I'm able to do. And I'm crypto first, and crypto is a core value. And those people will get massively accelerated, just like the internet first companies got accelerated when the internet's value became clear to users and all those other kind of business to business transactions that people care about now. And then you'll have enterprises that will be sitting there, and we talk to a lot of these enterprises, and I got to tell you, they're getting more and more astute by the month, really. I'm having conversations with people now that are much more informed than they were a year ago in the enterprise. Many people have stopped saying, I want to make my own blockchain where it's just going to be me and my employees and my one counterparty, and I'm going to win because I'm going to have an intranet. So a lot of that thinking is evaporating. People are looking for standards. They're saying, we use this standard, but we'll also have a capacity to interact with other standards. It's this dynamic around an evolution. The important thing is, where do people end up? The real question is, it is important that the crypto startups succeed. And it's great that there's all this value in tokens to let them succeed, because you can now build a crypto startup and there's enough private keys holding enough value to allow you to get a couple of $100 million in value secured on your product because you made a good financial product, right? In a crypto format, in a smart contract format. I think that's important. You see enterprises going more towards blockchains. I think the really important thing is the fundamental premise around cryptographically enforced, technologically enforced contracts. And when does that become valuable? And in what environment does that become valuable? I think that the environment that becomes valuable in is one of two environments. Either it's the environment where people have been able to successfully make a value proposition that users are absolutely 10x beating down the door to get, right? So some insurance company or some insurtech, some financial institution or a fintech or a crypto startup makes a financial product that gives users access or an ability to use a financial product, whether it's a derivative or some kind of less rate of lending returns. Like the lending returns in our space are way better than the lending returns in the traditional space. I still don't know why that hasn't taken off. Maybe it's because the on-ramps into that need to get better. But it's either that, and then people see that somebody's, like some bank is beating the other banks, or some insurance company is beating the other insurance company, or some insurtech got acquired by some company because that's all they do is this type of product. And then all the other companies kind of go, that's the future, I got to get it in gear. Or alternatively, consumers in mass come to the realization that they value cryptographically guaranteed agreements. And the people that value cryptographically guaranteed agreements are the people who have had traditional, non-guaranteed, brand-based agreements fail them. Like I can tell you right now that Wirecard users or Wirecard, participants are very sensitive to the concept of a cryptographically guaranteed agreement for them. And I think that in my generation alone, and also depending on how the world evolves and how many brand-based agreements are actually fulfillable or fulfilled properly versus not fulfilled properly for whatever collection of reasons. And there's these two kinds of forces, right? So either people start saying, I don't really like the concept of only being able to get 66 euros out of an ATM per day. I think I'm going to switch to a private key-based store of value where that can't happen to me. And why would someone think that? Well, they would think that because the neighboring country suddenly had that happen, right? When you saw the lockups in Greece for 66 euros per day, wallet numbers in neighboring European countries like Spain and others, where people worried about similar situations due to debt solvency and solvency questions, their wallet registration numbers, 600% growth improvement. So I don't know which of those is going to happen first. But I think it's definitely something that both of those are in the cards. What the timeline is on both of those, it's hard to say.
So that's a really interesting topic that feeds into the next question, which is, where do you see center of gravities emerging. So, typically Web 2 has been dominated by Silicon Valley and the West Coast. Of course, there's been an emergence of kind of the next generation of startups coming out of Asia. In that context of a demand for these kind of guarantees at a contracting level, where is there a center of gravity or are there centers of gravity?
I think it's really by region. What I see happening is that in specific regions, you see people adopting, sometimes due to regulatory requirements, like in China, where you have certain blockchain networks that are going to get mandated by governmental sources that people are going to have to use, just like they have to use certain applications and there's a firewall and things like that. And then there's more permissionless models where there's a more public kind of replication of the internet and that dynamic. I think it's really dependent on geography, and you're going to have an evolution of different industries and even different verticals having security repositories and other people launching vertically focused blockchain offerings. Then you're going to see the public internet version of similar infrastructures. Then you're going to see regulated and required kind of use of certain systems in certain other geographies. That's the dynamic that's there. I think the hopeful thing that I have actually is that you can have systems working in different geographies where, because they're all based on cryptography and because they're all based on this kind of veris and numeris concept of technologically enforced contracts, that you can actually still have guarantees across geographies without relying on a legal system or a political climate or something like that, right? I think that you're seeing a number of different blockchains adopted in different geographies, sometimes due to enterprise sales, sometimes due to government regulation. From our point of view, we're agnostic, so we support many different chains. Tezos, Hyperledger, Ethereum, Polkadot, a whole bunch of different blockchain environments. Many, many more on the way. We have over 50 blockchain environments already announced integrating with us, different stages of integration, different stages of going live with them. And so from our point of view, our goal is to enable the usage of smart contracts in all of these environments, and maybe even help bridge the kind of cryptographic proof that an abstraction layer would need to know about to guarantee that something is correctly happening somewhere else. The more important thing is that whatever blockchain system someone builds in their local geography, it's able to meet the requirements of providing proof to other blockchain systems. And that partly depends on how data interacts with that system. So if you have blockchain systems that are run by a single party, one node, and then that party also gives all the data to the system, I mean, it's tough to even call that a blockchain system, right? It's just difficult to say that. And so other blockchain systems might not put a lot of faith in the outputs or the transactions happening on that system, right? Whereas if you have some other blockchain system where you have 15 or 20 or 50 state-run entities, all separate entities, all running some blockchain, fine, it's a blockchain, but it's not permissionless. Okay, it has that property. But then the question is, how does that blockchain actually work in relation to data? How do the contracts on there, how are they controlled? So there's actually two orders of problems, right? There's how does the blockchain work? How do the contracts on the blockchain work? And I think once you meet those two requirements for tamper-proofness, then you arrive at a place where people can still rely on what's going on in different chains, even though there's different chains in use in different geographies. I think there will be a consolidation around certain types of technologies in certain verticals and for certain types of transactional data. So I think that'll happen. It's very difficult to predict. It depends on what vertical we're discussing, who the participants are. There's incumbents who want to make their own blockchain, but they're doing it sometimes the wrong way. There's pure blockchain teams that want to instill that, but they don't have the participation of a lot of the participants they need, the bank's participants and the hedge fund participants. And so those are very complicated questions. But I think everybody's kind of innovating in their respective geography to meet the requirements of that geography. But I do see more and more people arriving at standards. So I do see that there will be standards even across across geographies.
I think it's really interesting. It kind of reinforces that idea about where gravity will form. If I kind of extend what you're saying, it feels like whilst there can be chains or networks that are designed for a particular, to respect certain sovereignties, whether they're corporate or national, ultimately there will be a kind of a weighting in these systems about how much other networks will trust or apply a weight of trustfulness to what comes off those networks. And presumably economic value will flow towards those systems that have the higher level or higher order of trustfulness.
I think it's a competition between how much you want to do the deal and the risk that you take, right? Somebody wants to buy an asset in some country where they don't trust the legal system. They have a big problem on their hands, right? So they're weighing their desire to get the asset versus the risk of, I won't actually get the asset. I'll just get my money stolen, right? And it's a relatively similar dynamic. And so the thing that I think people should do is they should architect out their blockchain systems to enable usage both for their internal and local requirements and for usage by the outside world, because they need to meet that requirement if they have any chance of people using it in the future for basically international business, which is the type of business, globalization has made that the way that people work today. Even in the crypto space, it's a completely global industry, with exchanges and basically every part of it. So you basically arrive at a place where if you build a blockchain system or the smart contracts in the system work in a way that's very easy to tamper with, you diminish the usefulness of that system for external parties. And that's a serious loss, right? Because that's antithetical to what the system is supposed to achieve. So I think as long as the system achieves that, it achieves that at a high level of cryptographic proof, using well-made software, implementing certain key standards, and importantly, the contracts on those systems interact with data properly and they function properly as well. If those two requirements are met, both the blockchain functioning in a tamper-proof manner and the contracts on the blockchain functioning in a tamper-proof manner with the help of an oracle mechanism that makes that possible, that's when you arrive at a place where, okay, I have my locally generated chain for my vertically focused kind of use case of supply chains or derivatives in my specific country, but everybody can interact with that, right? So people can still interact with that. The global market of stable coin holders can still use my smart contracts on that chain. Will those people eventually say, maybe we don't really need to run a chain and we need to go to this larger, bigger public chain that has the scalability properties and the privacy properties and all these other properties that we had in our local smaller chain? Yeah, maybe they'll do that. That's very possible. Obviously, from what I mentioned, there's a lot of properties that need to be in those chains for them to do that. But yes, I think the important thing is that in the medium term, whatever people build as their locally focused variant or their industry focused variant, that both the blockchain works in a way that meets the requirements of a blockchain and the smart contracts on those chains interoperate with the real world in a way that they meet the definition of a smart contract in the sense that they're actually tamper-proof.
Yeah, well, look, Sergey, it's been fascinating talking to you. Thanks for coming on. I think you and Chainlink and the team that you have there, you're a living case study of success in Web3. We reference you all the time in our accelerator and the kind of first-time founders that we're working with. And I think you're really helping the space cross over into mainstream industries and break out of just kind of this crypto echo chamber. So thanks for coming on, and I look forward to watching Chainlink's ongoing success.
Great. Thank you very much for having me, Jamie. Great chatting with you again. Thank you.
If you enjoyed today's podcast, please make sure you subscribe, rate, and share your feedback to help us reach as many people as possible with the important mission of Web3.